Hello everyone and welcome back to the GCSE Maths Series. Today we're going to be taking a look at the gradient of a line. So let's get straight into it. So the gradient, or slope as it's sometimes referred to, tells us how steep a line is by measuring the rate of change between the vertical and the horizontal. And the way I like to imagine the gradient is like walking up a hill. If it's steep, the gradient is large. So steep equals larger gradient. And if it's flat, this is equal to a zero gradient. So the gradient tells us when I move across, how much do I move up and down? And it is, the gradient of a line tells us how much we move up and down as we move across. And the formula of the gradient is given by the change in y over the change in x. So this can be further defined as y2 minus y1 over x2 minus x1. And if you were to think about it, two coordinates, x1, y1, x2, y2, the difference between them is the gradient. So when we do, it tells us that how much does it change in the y direction divided by how much does it change in the x direction. And that is what the gradient is. So a positive gradient looks like this. A negative gradient looks something like this. And our zero gradient looks something like this. There is also another one, which I'm going to include here. An undefined gradient looks something like this. A straight line like that. So these are all lines. Undefined we won't really need to know at this level, which is why I didn't include it in the first place, but I thought I'll just bring it in here. So yeah, a positive gradient, you can see from here. A negative gradient is going downwards, down to the bottom right. Positive gradient going up to the top right, and so on. Okay, now looking at some questions, we have 2 points. So let's just draw this line like this, and we call this 2, 3, and let's call this 6, 6, 7. And we are asked to find the gradient of the line which passes through these 2 points. So we're finding out the gradient of this line. So we write out our coordinates once again, label them as in x1, y1, x2, y2. And using our formula, we have y2 minus y1 over x2 minus x1. So in this case, we have 7 minus 3 over 6 minus 2, which is equal to 4 over 4, which means the gradient is equal to 1. So it is a positive gradient, as seen in the diagram. So a straight line passes through the points minus 4, 5, and 2, minus 1. So here and here. Work out the gradient of this line. So we have our minus 4, 5, our 2, and minus 1. We have x1, y1, x2, y2. We have the change in y, so minus 1, minus 5, over 2, minus 1, which is equal to minus 6, over 3, which is equal to negative 2. Hence the gradient is negative 2. A line passes through the points A, 2, 7, and K, minus 5. The gradient of the line is minus 3. Find the value of K. So in this case, we can use our gradient formula to work out our K. So let's write out our gradient formula again. y2 minus y1 over x2 minus x1. Let's label our coordinates first. We have x1, y1, x2, y2. So we know that this is a representation or an expression for our gradient, which means that at some point, for some values of y2, y1, x2, and x1, the gradient or this formula will be equal to -3. So let's fill in what we do already know. So -5 minus 7 over k minus 2 is equal to -3. So let's first times through by k minus 2 on both sides to get, let me write this over here. We have -5 minus 7 is equal to -3 times by k minus 2. Then this is equal to -12 is equal to -3k plus 6. To get k alone by itself, we first have to minus 6 from both sides to get minus, actually let me make some more space. So we now have, from minusing 6 from both sides, we have -18 is equal to -3k. Then we notice that our k is being times by -3. To reverse this, to get k by itself, we need to divide by -3 on both sides, meaning k is equal to 6. So this is 6 minus 5, with k being equal to 6. Okay, that's going to conclude today's revision video. I hope you guys enjoyed the video. As always, please make sure to like, comment, and subscribe, and I'll catch you guys in the next video. Peace.